Okay, now we will bring out some essential difference between Coulomb's force and gravitational force, right? First basic difference is Coulomb's law. It exists between charged bodies. It exists only between point and static charges. I mean, for the electric force, the two bodies under consideration must be charged. Electric force can't exist between neutral bodies. While gravitational force, it exists between masses, I mean material bodies, right? So that's the basic difference. It exists between charged bodies, gravitational force, it exists between material bodies. Coulomb's force, it can be attractive or repulsive. We have discussed like charges that tend to repel each other while unlike charges tend to attract each other. So the nature of the Coulomb's force or electrostatic force may be either attractive or repulsive. While on the other hand, gravitational force, it is always of attractive nature. The gravitational force existing in two material bodies is always of attractive nature, right? Third, now Coulomb's force, its magnitude is about 10 raised to the power 36 times stronger than that of gravitational force. So, gravitational forces are the weakest forces in nature, while on the other hand, the Coulomb's force is approximately 10 raised to the 36 times stronger than that of gravitational force. So, if you compare these two forces, to electric force and gravitational force, it will be about 10 raised to the power 36. So these are much more stronger in magnitude as compared to that of gravitational force. So these are some basic differences. There are some other differences as well, like gravitational force. It doesn't depend upon the nature of the medium in which the two material bodies are placed. While on the other hand, we have just now discussed, Coulomb's force. It does depend upon the nature of the medium in which the charges are placed. F is equal to K Q1 Q2 by R square. K itself depends upon the nature of the medium. So F in turn depends upon the nature of the medium. So that's again a very important difference. The force between two material bodies is independent of the nature of the medium in which the two material bodies are placed, while on the other hand, Coulomb's force or electrostatic force, it does depend upon the nature of the medium in which the two charges are placed. Right? There are some similarities as well. Both the forces obey inverse square law. Both these forces are central forces. Central forces means both these forces acts along the line joining the center of the two bodies, whether they are charged bodies or material bodies, right? One more thing I would like to mention, mass without charge is possible, but charge without mass is not possible. I repeat, mass without charge is possible, but charge without mass is not possible, right? So, we were discussing some similarities. Both are central forces, both obey inverse square law, both are of conservative nature. This is a very important term, conservative nature. We have done it in +1 as well. Conservative nature means the amount of work done in making a body to move from one point to another against or by the force depends only on the initial and the final position and is independent of the path followed. So such a force is said to be of conservative nature, right? We'll mathematically verify this fact for Coulomb's force. We have done for gravitational force in the previous class, but we'll discuss it. So I think the relation is clear. Now what we'll do is, we'll try to express Coulomb's law in vector form. So we'll consider case 1. Case 2 you will consider yourself, and it's an assignment for you. We'll consider the case of Q1, Q2 greater than 0. We'll consider a system whereby these are the 2 point static charges, this product is greater than 0. So it is possible only when both are positive or both are negative. It means that we are dealing with like charges, right? And suppose they are placed in vacuum. These are the 2 point and static charges. Since they are like charges, therefore, they must repel each other. Suppose this is F12 and this is F F21. It is the force exerted by Q1 on Q2, and F21 is the force exerted by Q2 on Q1, right? And if you measure the distance from A to B, then suppose it is represented by R12 cap. It's a unit vector. Unit vector is a vector divided by its magnitude. It represents the direction of the vector under consideration. And in case we measure the distance from B to A, then suppose it is R21 cap. Now let's try to represent F21 and F12. So, F12 in the vector form. Vector means containing two parts, magnitude as well as direction. So, magnitude, we are aware it is 1 over 4 pi epsilon, or simply you can write K, or you can write 9 into 10 raised to 9. Here we are considering these two charges are to be placed in vacuum or free space. Then Q1, Q2 by R square. This is the magnitude. Now what about its direction? F12, it's directed from A to B, and it is represented by R12 cap. So here we will specify R12 cap, right? So this is a vector quantity, this is the scalar part, and this is the direction part. So unit vector, as you are aware, it can be written as vector divided by its magnitude, right? So it can also be written in this particular manner. 1 over 4 pi epsilon Q1, Q2, substitute this value over here, so you get R cube, and here we get R12 vector. Put this as equation number 1. Similarly, we can obtain for F21 vector, we can obtain expression for F21 vector. So it will be 1 over 4 pi epsilon Q1, Q2 by R square. This is the magnitude of F21. As I told you earlier, F21 represents the force exerted by Q2 on Q1. What about its direction? This is the scalar part. What about its direction? F21. It's directed from B to A. And that direction is represented by this unit vector. That is R21 cap. Again, unit vector is a vector divided by its magnitude. So we can rewrite the above expression as right. So the unit vector is replaced with vector. Now another thing, what's the relationship to R21 vector and R12 vector? Both are of equal magnitude, but they are opposite directed. So they are equal in magnitude and opposite directed. So in the vector form, we can write it as R12 vector is equal to minus R21 vector. Put this as equation 3. Now consider these three equations. Magnitude part is same. What about R21 vector and R12 vector? They are equal and opposite. So from equation 1, 2 and 3, what we conclude is F12 vector is equal to minus F21 vector. So, a question may be asked like this. Okay, what is the importance or utility of writing Coulomb's law in vector form? That we will discuss now. We have proved it mathematically. F12 vector equals to minus F21 vector. Equal means both are of equal magnitude. Minus sign over here means both are opposite directed. The angle between these two is 180 degree. These are the vectors. Force is a vector quantity and they are opposite directed. Negative sign suggests that the angle between them is 180 degree. So what do you conclude from this? This represents the very fact that Coulomb's force forms action-reaction pair. Means whatever force is exerted by Q1 and Q2, the same equal and opposite force is exerted by Q2 on Q1. So Coulomb's force, it always exists in pairs. So they form action-reaction pair. They form action-reaction pair. It means that both the forces are of equal magnitude but oppositely directed. Second, the angle between them is 180 degree, means straight line. So what I mean to say is that the Coulomb force is a central force. These are the forces which acts along the line joining the two charged bodies. Now this is the line joining Q1 and Q2. So F1 and F21 will be directed along this line. either away or towards, depending on the nature of the charges. So it's a central force. Central force means force acting along the line joining the two bodies. So these are the two importance of writing Coulomb's law in vector form. First is, it verifies the very fact that Coulomb's law form action-reaction pair, that is both these forces are of equal magnitude but opposite directed. And second is, it is a central force. It always acts along the line joining the two bodies.